Greetings! In this video, we are going to show you the brief concept about modulators for data communication by Synopsys Photonic Integrated Circuit Design Suite. So what is modulators? As we know, in order to transmit signal through an optical link, such as single-mode fiber or multi-mode fiber, the electrical signal must be converted to optical signal, normally by modulators or direct-modulated lasers. If we look into the structure of the transmitter, we have CW laser source, we have data source, which is the source of our signal, and we put the data source into electrical driver IC, we got electrical signal, and we put the light laser source with the electrical signal into the modulator, then we got a modulated an optical signal. So normally there are two main properties which can be modulated in modulator, that is amplitude and phase for optical signal. If we talk about the amplitude or the intensity, we have intensity modulation. We can put our signal into the amplitude of the optical signal. If we would talk about the phase modulation, we can put our signal in the phase of for the optical signals. So when we talk about the format of modulation, signals are packed by modulators, and we can modulate the amplitude or the phase. So at first we have PRBS signal, which is the logical signal that we're going to transmit through this system. And then we put the signal into the electrical IC, we got electrical signal. So please note that the unit here is the real part of signal, that is volt. And what we need to do is convert this electrical signal into the optical signal. So please check the note here. It should be like the milliwatt or watts for amplitude modulation or degree for phase modulation. And then we can put out a signal into the optical transmission signal here. So if the signals are modulated by the amplitude of optical signal, this is what we call amplitude modulation or intensity modulations. So normally there are two formats: post amplitude modulation 2 level, what we call PAN2 or binary signal; post amplitude modulation 4 level, which is PAN4. And for PAN2, what we call not binary, amplitude of optical signal are modulated directly based on the signals. For PAN4, the amplitude of the optical signal are modulated for 4 levels. So we are able to pack two sets of data signal in a one single transmission. So in the right hand side here, this is the PAN2, the binary signal for optical signal. And in the left hand side, this is what we call PAN4 optical signal. We have 4 level optical signal in this system. So in order to include two sets of data, we have 4 kinds of combinations in this transmission. So imagine that we have two data set A, data set B, and each of them has the 0 and 1 for each signal, and those we have 4 combinations. We can set up that for 0, 0, we can set up the power level as 0. For 0, 1, we can put it in the power level 0.2. For the data 1, 0, we can put it like 0.4. For data 1, 1, we are able to put it into the data level 0.6. And then if we check the eye diagram, now we have 4 different levels of signals representing different kind of combination of our signal data A and data B. So by decoding the output signal with these rules, we are able to decode the original data in the end of receiver side. So we talk about that. What is the benefit for PAN4 modulation? So it's obvious that PAN4 track the SN ratio for two signals. So that is, it doubles the bandwidth, but divide the SN ratio by 3 because we have 4 level. So in the case here, the original SN ratio for PAN2 for binary signal, this is the SN ratio for the original set. But now we are able to transmit more data, but the SN ratio was reduced to this set. So that is, PAN2 only carried 1 set of data, but now PAN4 carries 2 set of data. And if we have more and more SN ratios, we can either use the PAN8 or PAN16 for this modulation. In photonic design suit, Synopsys Photonic design suit, a demo fab PDK based PAM4 transmitter is designed, and it was used the demo fab PDK, which is public for all the users of Opsin circuit without signing any documentation. So by using these applications, our users are able to directly check the working principle for PAM4 system, and you are able to use our another foundry PDK in Opsin circuit to design your own transmitters. In this case, we have 4 electrical modulators by demo fab PDK to generate a PAM4 signal, and we have 2 electrical modulators for 1 set of signal. So that is, we are able to transmit 2 sets of data as we described. So now the eye diagram is very good for this case, and the schematic here is the PAM4 chip. You are able to export this schematic to Optical Designer for layout generation. For simulation part, you can consider electrical components like paths or electrical connection, transmission line in simulations. And these components will introduce more reflection by impedance mismatch in simulations. So also, these electrical parts are included in demo fab PDK libraries, and we can put that into simulation. So when we do the simulation, we can check the effect of these electrical components and the reflection caused by these components because of impedance match or mismatch. And we have more studies like the segment electro-magenta modulators PIC design suit, and we provide this application. We demonstrate the modeling of a PAM4 transmitter. Instead of the previous design, we use the segmentic magenta modulators made from discrete PIC elements of Opsin circuit here. This is another new concept, a new type of design which use less electrical power consuming in this case. So we talk about amplitude. What about the phase? Also, if the signal are modulated by the phase of optical signal, we call it phase modulation. So in the same thing, if we modulate it in 2 levels, what we call BPSK. If we modulate it into 4 levels, we call it QPSK. So in this case, the signal are hidden in the phase of our optical signal with 4 levels, what we call QPSK. If we check the real part and imaginary part of this case, we have 4 major points in this constellation diagram here. So that is, we divide the whole region, the phase region, by 4 different points. That is QPSK. In Synopsys Photonic design suite, we also provide a demo fab PDK based QPSK modulators for our users to experience the working principle for QPSK. So please feel free to ask it. This video, we're trying to provide the optical modulators with modulating the amplitude and phase, and these applications are widely used in data center communication. Synopsys provide a complete solution for designer to design the modulators with various foundry PDKs, and also we provide a bidirectional interface between schematic to layout. That is, you are able to use the schematic in Opsin circuit and design the schematic by the simulations. Export your design to Optical Designer for layout generation. Besides, in Synopsys PIC design suite, both modulations with public examples are available, like PAM2, PAM4, BPSK, QPSK, 8 QAM, 16 QAM, or even 16-4 QAM example. So feel free to ask an online customized demonstration with our experts. Thank you for your attention.